Well, I'm excited, of course, as always, to talk about kidney disease in general, but we want to talk a little bit more specifically about where I really think the uremic toxins are a concern, and more importantly, why, and how that really relates to clinical medicine as you see it. I think it's not something that we've really thought very much about in the past, and so that's why I want to really give this a very clinical relation to what you're doing in your everyday practice. So let's start by talking a little bit about what do I really mean by uremic toxins, and we'll talk about some in particular. But I think it's important to realize that there are actually many uremic toxins. And again, when we think about what we clinically evaluate in our feline patient, we really only think about creatinine and BUN. That's what you see on the lab work, that's what we measure. And those are uremic toxins, but they're actually one of over 100, almost 150 different substances that build up with decreased GFR. And not all of these substances are bad for the body, but actually many of them are. And so that's what we want to think a little bit about more is what is the effect of that and what does that really mean for the body in general? And so the one specific uremic toxin that I will talk a little bit more about will be indoxyl sulfate. That's one that's probably received a lot of press. There's a lot of publications on it. I remember the first time I went to a human nephrology conference, and I was just shocked by the number of posters and presentations that were talking about uremic toxins. And I thought, wow, this is not really something that we think about in veterinary medicine, and we probably should be. And what we need to know about uremic toxins is this very much relates to the gut, and it's a story about protein too. And that absolutely relates to the story that we should be thinking about for feline kidney disease. So when we think about the formation of these substances, they're produced in the colon as a result of protein fermentation. And unfortunately, the production of these substances is increased as the result of gut dysbiosis. So you basically end up with a population of bacteria in the diseased gut that's producing more of these substances. So the bacteria become selected for the ones that are actually focusing or not focusing on, that's giving bacteria intent, but they are producing these uremic toxins. To look at that a little bit more schematically, think about how the dietary protein goes into your gut. And if we're talking about indoxyl sulfate in particular, tryptophan is actually the precursor there. So then bacteria in your gut take that tryptophan, and as a result, they're producing indoles. That's then absorbed into the body, and it goes to the liver where it becomes indoxyl sulfate. Now, here's where the problem results. Indoxyl sulfate is going to be eliminated by your kidneys. And then when you have kidney disease, you're not able to do that effectively. That substance is going to be one of many that builds up into the blood as opposed to being eliminated into the urine. So you have this interplay between the gut and the kidney. And that leads us to what I would refer to and the literature refers to as gut renal syndrome or the gut kidney axis. You'll see this in the literature. There is back and forth interplay between the gut and the kidney, and the illness in one affects illness in the other, and then they tend to exacerbate each other. So we really have to think about, that uremic toxin production, it's natural, but then it becomes a problem potentially when you have kidney disease. And then that feeds back and has a negative effect on the gut as well. So you get kind of a nasty circle of these toxins that potentially are a concern. So that's the concept of gut renal syndrome and how the two feed off of each other.